In screencast 20.5, we have a balancing redox problem. In this case, we're going to solve the entire thing on one slide. So if this is too brief for you, there was a 3-slide one that we did earlier. So you can have a look at this one. So this one we're going to solve rather quickly. The question says we've got some iodide that's being oxidized to iodine using permanganate, which turns from MnO4 minus to MnO2. So what they said was right there, the permanganate goes to manganese 4 oxide. The iodide turns into iodine. So let's separate that now into our two half reactions. The oxidation number is for iodine. Where are we? There it is. Looks like we have an answer here. Let's see if we match it. So iodide to iodine, fine. It goes from -1 to 0. Remember, oxidation, you're going to a higher value since you're losing electrons. And permanganate gets oxidized, and if you do the math, you'll see it's going from +7 to +4. Let's balance the iodine because we got 2 here, but only 1 there, so we're going to double it. Good, we're balanced with respect to iodine. And the electrons we can do as well because there's no oxygen that we need to use water for, anything like that. So we are -2 on this side and 0 on this side. I think we need 2 electrons on the right. So that's good for the oxidation part. Let's work on the reduction part. It said permanganate goes to MnO2, which is fine, except we need 2 more oxygens, so we add 2 water molecules. We now have 4 hydrogens to deal with. You may recall we had 4 H pluses to this side. And we're all messed up in terms of charge here. It looks like we are 3 plus here and 0 there, so we need to add 3 electrons to the left. And that's nice. We are now ready to combine. Write them both down and add them up. And before we do, let's balance the electrons because look, 3 electrons here and 2 there. We better triple everything here and double everything there to give us 6 electrons that will cancel out. So this gets multiplied by 3, that times 2. And normally when you do these, if you just try to not do it out first, in other words, try to keep track of that is 6, that is 6, that is 6, and cancel terms, and you can quickly or more quickly get to the what looks like the final answer, but there's one thing we're forgetting, and that's that this is in basic medium. So for every H plus, let's add an OH minus, and that certainly will make it basic, because this will turn into water. We have to do it to both sides, so we'll have 8 OH minuses on the right side. And if you check everything, you should have a balanced chemical equation. Now I always like to turn this into something real because after all you can't buy iodide, but you can buy potassium iodide. So I randomly used potassium for my cations, and is that all I needed to do? It could be, and that would give us a reasonable actual balanced chemical equation. Now if somebody asked you to balance that and you got rid of those numbers, it would be difficult. So that's really what this is all about, is trying to balance a challenging balancing problem. And this is Screencast 20.5.